Aloha, Richard Halverson here. This is ITS228, and today's March 31st. Let me share my screen. And let's see, 228. And let's see, I owe you an assignment, which I am not finished writing up, but I'll get to that. Today is, we are in here, 11, so let's talk about sets. I'm not going to spend a lot of time talking about sets because it's not that important to actually spend time talking about this because Python has sets in it. It's sets is a built-in data type in Python, but it's not in any other language, pretty much. So, and this is a algorithms data structures programming class where we learn the data structures that are commonly used in algorithms in computer science. And so sets is a data structure. One of the things that's so nice about Python is lists and sets. It's got them built in already. So we don't have to spend a lot of time studying it. But you still should go through this because you're not, if you go out into the real world and you become a programmer, you may already be a programmer. If you are, you know that you're not always going to be programming in Python. You're going to be programming in lots of different languages. And so you need to know the basics of these kinds of data structures. So if it becomes appropriate to use something like lists or sets and you're writing code in Java, then you're going to want to know this stuff. So let's take a look and see what there's not much here. It introduces the set abstract data type, and a set is a collection of distinct elements. A set, there's an add operation to add an element. With sets, like in Python, there's sets and lists and tuples, and they're all different, having to do with whether they're ordered and whether or not it'll take duplicates. Okay, so sets doesn't take duplicates and they're not ordered. A tuple doesn't take duplicates, but it is ordered. Let's see. I brought an I did a search on it, and so a set cannot take duplicates. Oh, but a list or a tuple can take duplicates. What's the difference between a tuple? Let's talk about a difference between a tuple and a set. Let's just quickly see what that is. A tuple has an. Does a tuple have an order? Let's see. Mutability is a set is mutable, a list is mutable, but a tuple is not mutable. That means you can't change it. It means if you pass a tuple as an operand to a method, the method cannot change the tuple. Whereas a method can't add to a list, it can add to a set or take away. Both tuple and lists, list and tuple. Set versus list or tuple. If you want to store duplicates, use a list or a tuple. If you do not intend to mutate, go for the tuple. If you do not need to store duplicates, always go for the set. And the thing is these, if you're using these data types, especially in Python, then like this adding an element to a set, that method will not let you add a duplicate. Okay, so the data structure enforces the rule that you would want if you're choosing a set. All right, so it's an unordered collection, and so this makes sure that you understand what exactly a set is, and in Python, a set is declared using these curly braces, just like a dictionary, and there's a reason for that, because sets are not ordered, dictionaries are not ordered. I can't remember. Our tuple lists are ordered, and I guess our tuples ordered. I can't remember. Anyway, oh. I think they both must be ordered. Okay, so make sure you understand this, which is not a valid set. This is not a valid set because it's got 228s, which just makes it not valid. So, okay, element keys and removal. This just talks about those functions. A common or a defined method for sets is removing an element, and so here we pass in the set itself, and we pass in the key to remove, and it finds it and it deletes it if it finds it. If it doesn't find it, it doesn't delete it. And a set is mutable, so when it's done, the set will have changed. This talks about searching for subsets. Obviously, X is a subset of Y if and only if every element of X is also an element of Y. And this will, let's see what this is. Let's do this one. Given an empty set, what is the num set after the following operations? Okay, we're going to add a 16, we're going to add a 94, we're going to add a 32, and we're going to add a 96. When we try to add the 16, it's not going to work. So it would be 16. Let's see how it writes. Okay, it does put a space. 16, 94, 32. Not 16, but 96. Right. Okay, so here it talks about the set operations. Union, of course, when you take all the elements in the first set and you add to the set all the elements in the second set, but of course duplicates don't. You exclude the duplicates. The intersection is those elements that are in both sets, and the difference is the first set minus all the elements in the second set that are all the elements in the second set that are in the first set. So there can be a bunch of elements in the second, the one you're subtracting. There's the starting set and then the set you're subtracting. There can be a whole bunch of elements in the set you're subtracting that is not in the set you're subtracting from, but those that are in the second, those are taken. So that shows that. And it's not an error if there's elements in the second set that are not in the first set. All right, so that describes that. These are what the operators look like. So this here it shows the pseudocode for these operations for unions. You go through for each other. You're going to return a set. So you're going to take in the two sets and you're going to return a third set. So this is the new set, and you're going to add all the elements from the first element, and then you're going to add all the elements of the second element that aren't in the first element. That's it. And intersection it can do this by taking for each element in the first set, you check to see if that element is in the second set, and if it is, then that element goes into the returned set. And this is the algorithm for difference, and you can see how that works. And this makes sure that you understand how these operators work: union, intersection, and difference. Let's see, 83.5 minus 977.83 would just be 5, because you take the one you're subtracting from, and you look to see if there are any elements in the one you're subtracting that are in the one you're subtracting from. And if there is, those are the ones that are removed. The ones that are not in the terms subtrahend and minuend. Subtrahend and minuend. Those are the two. A number from which another number is subtracted. So there's the minuend and the subtrahend. The subtrahend is the one you're subtracting. The number from which the subtrahend is to be subtracted is the minuend. So if you want to be fancy, you can use those terms. This is the minuend and this is the subtrahend. Anyway, so the answer is 5. All right. A filter operation on set X produces a subset containing only elements from X that satisfy a particular condition. And the condition for filtering is called the filter predicate. And so I guess the function that takes an element as an argument and then returns a Boolean value indicating whether or not the element is in the filtered set. All right, so this explains these methods that are used that go along with sets when you are using sets, the set filter and the set map. And these are examples of a filter predicate. This is going to return just even ones. This is just going to return true or false. It returns true or false. If it's above the element's greater than 90, you know, if it returns the ones digit of a number. Kind of interesting. All right. So here's some other ones here. So go through these participation activities and make sure you understand all these different kinds of methods that can go along with sets. All right, let's do one. Given these two sets, what is the set union of set A and B? Well, I would say that it's 82, 77, 30, 70, 57. And what is the intersection? I would say, is 82 in both? No. Is 77 in both? Is 30 in both? Yes. That's it. So there. All right. So 9.3, your static and dynamic set operations. I don't know why that happens. What is that? A dynamic set is a set that can change after being constructed. A static set is a set that doesn't change after being constructed. Okay, so Python sets are dynamic sets. A collection of elements is commonly provided during the construction of a static set, which is because you can't add to it. A static set constructed from the list of integers would be, you know, something like this, because there's no, you don't have the duplicates in there. So here's some differences between static and dynamic. If you have a static set or a dynamic set, let's see what. I guess yeah. Is there? It'd be interesting to create using Python sets, create methods that would allow dynamic set operations. No, I know static. No, that would emulate static sets. Maybe that's not so interesting. Anyway, so but if you're gonna use sets out and your programming language is not Python, or if you want to use sets but you want the sets to be static, then you got to do something in addition to just using a simple Python set data type. And so this makes sure you understand that. Choosing for a real world data set, select whether a program should use a static or a dynamic set. Periodic table of elements. I guess static. I don't know. Do we consider that they're coming up, that they're finding new elements? I guess it is static, because you wouldn't want to add or remove them, I guess. Okay, collection of names of all countries on the planet. I guess static, unless you're going to talk about a new world order or something. List of contacts for a user. Well, I'm going to assume that the user is alive, and I will say dynamic. All right. Okay, here we talk about set implementation in Python. And again, this assumes, well, this was written, this code is written not considering the built-in set data type. Okay. And so if you were doing this in any other language, if you're implementing sets in any other language, and in fact, perhaps the way it's actually implemented in Python underneath is they use a binary search tree. And so this talks about how you use a binary search tree. And then on top of that, you start out with a binary search tree class. And then on top of that, you add a bunch of these methods that will let you implement the standard set methods. And here we introduce this iterator class, which is an important class in which is important in lists, and when you're iterating through, it introduces this underscore init method thing, which we already know about. This textbook is designed for somebody that is familiar with another language and perhaps even learned a lot of this stuff already, and then they're just learning Python for the first time. Because we obviously know about this. We learned that in 128. And then here's a class definition of a set. Here's an iterator, adding to a set, binary search tree, adding to a binary search tree, and then this is the operators for the methods for implementing the difference function, filter function, intersection function, and so on. So I'm not sure if I'm going to have you implement this. I think I may do something like have you take advantage of the fact that we know Python, and we can, some of these functions that they're having us do are actually much more easily implemented just using the Python built-in methods. All right, so that's what that would be. All right. So, this isn't a very long chapter. Just make sure you click through and you get all the participation exercises. It's not that important because we have sets. We use sets in Python already. We learned it in 128. Next time we're gonna get into graphs, which is a very important data structure. It's in any kind of programming, in anything. So it's we will be there's a lot to graphs here. All right, so that's all I have for today, and I will see you next week. Thanks for watching.